Okay, so here we go. This is section 5.6, inequalities in two triangles. The biggest problem with this section, honestly, is the theorems are long. There are two pretty long theorems in the hinge theorem and the converse of the hinge theorem. But again, we're still working with triangles and proving relationships within them. So, first of all, we used inequalities to make comparisons within one triangle. Uh, we did that back in section 5.3, and we talked about the fact that the exterior angle is more than its two remote interior angles individually. We also then we talked about the bigger the opposite side, the bigger the opposite angle. Well, now we're going to talk about what if we have two triangles? We have two triangles that are very similar. How can we work with those? And talk about the hinge theorem and its converse. So first of all, let's go to a little online thing. And again, I'm stealing this from somebody else. I have one made, but I couldn't find it on my computer, and I was too lazy to mess with this. So here's what we have. Right now I have two triangles congruent. Okay. I've got side, well, I attempted side angle side, but the thing is a little off. This is 40.5 and 40.4. But we have side angle side essentially. Or we can even think of this as side, side, side. Okay. So what we have is we have two triangles where they have two pairs of sides congruent. Okay. To begin with. Now, here's what happens. On this drawing, I can't change the length of AE and AC or BF and BD. Those two guys are fixed. Two sides are guaranteed congruent. And that's the first part of the hinge theorem. You have two triangles where you know two pairs of sides are congruent. Now the question becomes this. What can we say about the third pair of sides? Okay. Or what can we say about the included angle? Because remember, side, angle, side, side, angle, side. So what can I say about either of those? Well, here's the deal. If I make the third side bigger for one triangle than the other, watch what happens to the angles. It gets bigger as well. Okay. So what ends up happening is I've opened up, which I call this the hinge theorem, I've opened up the door more. I kept the two sides the same, but by opening up the door, what that does is it makes this side bigger and this angle bigger. And that's how the converse works as well. It says, okay, let's say you don't have the opposite side lengths. We don't have an opposite side, so I'll get rid of the sides. Well, if I make the angle bigger, what happens to that third side? So we have side, two sides congruent. Now we know what one angle is bigger than the other angle. What does that mean about the opposite side? Well, it also has to be bigger. Or if I shrink that opposite side down, or I shrink that included angle down, I make the included angle only 20 degrees versus 40.4. Well, what happens to the other side? Oh, it's smaller than the third side. Okay, so again, we call this the hinge theorem because it's like opening up a door on a hinge, comparing the two of them. So here we go, the two inequalities in triangles. So first, the hinge theorem. If two sides of a triangle are congruent to two sides of another triangle, and then this is the key here, in the included angle, okay, sorry, let me kind of stop in here in a second. Both of these are the same in their initial if part of it. Again, if two sides of one triangle is congruent to two sides of another, or are congruent. Again, if two sides of a triangle are congruent to two sides of another triangle. So we have to have that first. We have to have the two pairs of congruent sides first. What the hinge theorem says is if the included angle is bigger on the first than the second, then the third side is bigger on the first than the second. So the hinge theorem bases itself upon the angle. The converse says, okay, if the third side is longer than the third side of the other one, yeah, sorry about that, it's really sloppy, isn't it? Then the included angle measure is bigger from the first to the second. Okay, so here we go. So here's our first problem to try. Okay, so I'll go to my slideshow. There we go. Or my drawing. So here we're going to compare the given measures. So I want to compare side length JK and side length MQ. Now what I have to do first is I have to establish through the hinge theorem that I have two pairs of congruent sides, which I do. KL is congruent to PQ, JL is congruent to PM. So they make these two sides meet together to make this angle. So once I do that, the question is, what am I comparing? Am I comparing a side length or an angle? And I'm comparing sides. I'm comparing JK to MQ. So the question is, are they equal? Is one bigger? Is one smaller? We'll look at the angles. Angle L is 72. That's bigger than 61. So the opposite side has to be bigger than the other opposite side because this one is opened up more. So JK is bigger than MQ. Now, on problem 1b, again, we're using the hinge theorem, but what I have to have is two pairs of congruent sides. If you look at this drawing here, you might say, well, I only see one pair of congruent sides, 8 and 8. But RT is congruent to itself. Why? Okay, so coming back here, hopefully you've said that RT is congruent to itself because reflexive property. So we have two pairs of congruent sides, RS and RV, and then RT and RT. So now I'm trying to compare angle SRT, which is this angle here, to angle VRT, which is this angle here. And the question is are they equal? Is one bigger than the other? Okay. And here's the key. Angle SRT is opposite the smaller side. So angle SRT has to have the smaller opposite angle, meaning that SRT has to be less than VRT. Okay. So that's one way to use the hinge theorem, and the converse basically is just comparing two triangles. The other way is in a problem like this. We're going to find a range of possible values for A. So I'm trying to solve for making sense of angle A in this problem. Okay, so here we go. First of all, if I'm going to use the hinge theorem, I have to know two pairs of sides are congruent. Well, they've marked one pair of sides for me, LD and ND. What they haven't marked for me is MD. But I know, again, that's congruent by reflexive property. So we have two pairs of congruent sides. Now what I'm going to compare is the included angles, because I know one but I don't know the other one. That's what I don't have. That's what I have the variable for. Well, in order to do that, what I have to do is to say, okay, well, if that's true, then what is the opposite side? What's the relationship between the opposite sides? Well, ML is 18, MN is only 16, so ML is bigger than MN. That means that the angle of 141 has to be bigger than the angle of 9A plus 15. Now it says, find the range of possible values for A. Okay. Well, basically what that means is that we have to figure out what could A be between. And the key is A can't be 0 either. So we know this. We know that 9A plus 15 has to be greater than 0, and that it has to be less than 141. So it has to be between there. Now we haven't solved compound inequalities for a while, but you did do it in Algebra 1. So again, why did I set it greater than 0? Well, that's because an angle can't be 0 degrees or less. Why did I set it less than 141? Well, this is 18, this is 16. That means this is larger than this, so this has to be a larger angle than the other one. So how we solve compound inequalities? You start from the middle, subtract 15 from both sides. Okay, that gives me negative 15 is less than 9A, which is less than 126, and then divide everything by 9. Okay, this reduces to negative 5/3 is less than A, and then 129, we go into 129, or sorry, 126. I think it goes into it, yeah, 14 times. Yeah. So we know that A has to be greater than negative 5/3, but less than 14. Because if it's more than it's 14 or more, that means that actually this should be the bigger opposite angle. And if it's not more than negative 5/3, we'll get a negative angle or 0 for this angle here. Okay, so hopefully that makes sense. We'll talk more about this, especially problems like this, in class. So for homework tomorrow, okay, this just says use an inequality to describe a relationship. Also solve. You know, set up your inequality, and solve. In the triangle here, the relationship. Now here's your hint. This time, instead of talking about angles like we did on the previous problem, now you're talking about side lengths. So 12x minus 7, 3x plus 2. Okay. All right. So Yeah, I'll see you tomorrow. Have a good day. All right, thanks.